Great. Good morning, everyone. This is Vibhor Bansal from eGov Foundation and Partnerships team. Uh, we are initiating this DIGITx Bootcamp, which will run for 3 days. Today is the first session. Next session will be on 26th, 26th May, and the third session will be on 2nd June. Today we'll start with designing a digit service, which will be done by Ghanshyam Rawat. Ghanshyam is a principal architect with eGov Foundation. He has been involved in design and development of Digit since its inception. He is the best person to explain Digit. Today, Digit platform powers many products being built by ecosystem to enable services delivery to millions of citizens. Ghanshyam will share the thinking behind designing large-scale platforms and service delivery. This session will be followed by a session by Aniket on 26th May on how to install Digit, and then by Subhashini on 2nd June on how to develop a new service on Digit. This is the first session in the series, and we are uh, this is the first session in the series of these bootcamp. Uh, at the end of the session, there will be a feedback form. We would appreciate your response to it. This will help us design the series better as well as make these sessions more impactful. An important announcement is that whosoever is complete these 3 session series will be invited to a in-person special session at eGov, date for which will be communicated to those who will attend all 3 sessions. So we'll appreciate your participation there. Uh, I would suggest, as from my as my personal experience, it will be great as uh, doing things at your end as Ghanshyam explain these to you, right? That ways you will know how easy it is to work on Digit, designing a service on Digit, building on Digit, or installing Digit, right? So I will not take much of your time here. I'll hand it over to Ghanshyam. Ghanshyam, over to you. Yeah.
Hello. Just confirm if you can hear me. So first of all, thank you to joining this session. Uh, Let me just share my screen. Oh, before I jump onto the, designing the services onto Digit with the using, Digit principle and all, I just want to talk about the architecture. What do you understand by architecture, software architecture? So this session will be divided into four steps. First step is basically what was the monolithic architecture, and second is the problem what we were facing in monolithic architecture, how we have solved in microservice architecture. Then the government domain we will be talking about, why we have implemented the microservice architecture first of all, okay? And then how to design a service, including the API specification, what we will talk about. So when we talk about the software architecture, it is important to understand it is similar like laying the layout for your house, okay? You when you build your house, you design on the paper your layout of your house, right? All the rooms, kitchen, washroom, lobby, common area, everything you design, right? And then you build the house. Similarly, architecture is also like exactly same process, where you define your component, okay, and connect your component to deliver the functionality, right? So the I'll start from the monolithic architecture, okay. So I believe that you have a basic understanding of, the software and software architecture. Doesn't need to know everything how, the flow works, that I will explain in this session itself. Start from very basic. So the first slide, what we will be talking about, evaluation of the software architecture, right? How it was started, what all problem we faced, and then, we made the improvement in the architecture to resolve those problems and issues. So the single server setup, this is the most typical, simplest, monolithic architecture, which is used in many of the companies. Okay. And first of all, we should not think about the monolithic architecture are bad. Okay. It's about need. At what scale, what is your requirement? You want your deployment to be done. Depends on the requirement, which architecture fits into your use case, right? So this is a simple use case. If you see what we have here, a single server, which is in the bottom right, a single server. We have web browser, mobile app, and there is a DNS server. So what we do first, let's just take an example. When you hit the google.com, okay, I believe everybody do the Google, right? So once you hit the google.com, how does it know where I need to go and what page I need to load, right? So there is a DNS server available for that. Once you hit the digit.org, let's say, okay, the DNS server has the host to IP mapping. IP is the unique identifier of your server, where it's the address basically, like you have the house address, similarly you will have the server address. Volume. How? किधर से? Problem हो रहा? You guys can hear me now? Okay, thank you. I will use like this. Okay. So the first request, if we will go sequence by sequence here, the first request goes to the DNS server, and DNS server return with the IP. And for that IP, you server. It's a single server deployment, very simple. From the maintenance perspective, okay, resource perspective, and the ease of deployment perspective, right? You don't need a DevOps to deploy this kind of architecture software, right? Second is performance. Of course, because there will be no network latency. There is a single server available. Once you are connected to the server, then there is no further interaction required, which I will talk about later in microservice architecture. There is a network latency we face because of the inter-service communication, right? Easy debugging and troubleshooting and cost effective.
Audio because of the restarts.
Okay.
Just repeat what you said in the.
Okay. So the first slide, what we have seen, right? This one. I'm just explaining the pros and cons of this kind of deployment and architecture, right? Software architecture. So the pros is it is simple to deploy. You don't have too many components which you need to manage. Then performance, because there is no network communication once you connect it to the server. So performance will be better. Easy debugging, because you have a single server, you don't need to look around multiple services and all. You will understand these things better once I will talk about the microservice architecture. And cost effective, because it's a single server deployment and it is not for high scale requirement, right? If your need is you want to deploy it for the scale, then that's not the architecture we should go with, right? The cons, this is more important, because these are the cons we will try to solve one by one in subsequent slides, right? Scalability is a huge issue here, right? Because your database and your application is running on a single server, right? So the server need to be powerful. So scalability is an issue, because if you will scale it, you will need to scale everything together, right? Lack of fault isolation. What is fault isolation basically? If your server is crashed or down, that means the whole application is down. It is not like one functionality will be down. You might have seen that if you are using UPI and all, right? Sometimes payment doesn't work, right? But other things work. If you have balance in your wallet account, you can still do the recharge and all, but your payment might not be working, which is through UPI, because the bank is not available. But if they had, just think about if they had the same deployment, then everything would have been failing, because the whole application is failing now, right? Then development challenge. Basically, the application, once we will have a new requirement, then evolving a monolithic single server architecture is a bit difficult, because if you have so many modules within that, if one person is changing some feature and you need to test the whole thing, right? Because you don't know, they are tightly coupled. It is not unbundled completely, it is tightly coupled. So there are chances that can break things, right? So development is not easy. And tech flexibility, when we talk about, if you are writing a monolithic application in Java, then you cannot do, okay, one feature I will do in Java and one in .NET, one in Python, right? You cannot do that. So there is no tech flexibility. If it is in Java, you need to have the Java resources, and the complete development you will do in Java, right? Now, I'll just go back to the first slide. If you see here, this is a single server deployment. Okay, single server, no database and application deployed on the same server. Now, we are talking about the DB separation. So DB is deployed separately. That way, at least we have scaled the monolithic at some level. The failure now is not on the single server. If database is separate, and this still, if any one of them goes down, the whole application goes down. But if everything is together, because they are together, your hardware can crash. Now, if they are separated, at least you have distributed the hardware capabilities separately. Right? The flow is same. I'll just go in sequence. Now we'll talk about a little bit on vertical and horizontal scalability. Now, what is vertical scalability? Basically, adding more power, more CPU, more RAM to your hardware, right? On a single machine, let's say your laptop, it has 4 GB, you go with 6 GB, 8 GB, right? But how long? Right? If your scalability need 1000 GB of RAM, then you cannot keep adding the hardware into it, right? So vertical scalability has some hard boundary, right? You cannot go beyond that. Like your car fuel tank, there is a hard limit, right? Maximum you can fill this much. So similarly, vertical scalability works, right? What is horizontal scalability? Horizontal scalability, basically, you are deploying your application into multiple machines. Okay? You are distributing basically your application itself. Now, advantage of having horizontal scalability against vertical scalability anyways will be there with any of the architecture you follow, right? But with monolithic, you have only way is to vertically scale, right? Now, if you need to do the horizontally scalable in monolithic architecture, then what? Now, that's the important question. Can you do it? Some people think the horizontal scalability is not at all possible in monolithic. No, that's not true. There is horizontal scalability in monolithic also. Let's talk about this architecture, right? Where if you see the top layer is same, what we have now is the load balancer. Now we are deploying our application onto 2 different servers, and load balancer is managing the load for these 2 servers based on any algorithm, round robin ho sakta hai, anything, right? Now we have deployed it, but the problem with this, you are scaling the complete application, right? Not one piece of it. Whatever you want to scale. If you want to scale the payment, you know, March May, there are so many payments happening for the property, let's say. Okay. Then I want to only scale the payment, not everything. But with the monolithic, the problem is you need the same power machine and you will need the same infrastructure to scale your payment alone. Although other things will not get used that much, right? So that is the problem with this architecture. Now, in the previous one, if you have seen, there is one server for the database. Now, the next one, you see, we are scaling a database also. So what we have is the master slave for database, which is like master me, you do the right operations and read from the slave database. So that way, at least what you are doing is releasing some pressure from the single database server. If it is like heavy operations, heavy queries you are running, your write will not fail because somebody has wrote the bad read query, right? So this is what is the DB replication, right? So this is till now is monolithic. Okay, let's try to understand. This is still monolithic, although we have scaled the monolith to the certain level. Now we can go beyond that, but this much is, I think, good enough to understand the further things like microservice architecture and digit design. But we can talk about the CDN, right? We can talk about the cache then. These things can be further implement to improve this architecture further, right? So we can do that, but I don't think it is needed for today's session. Now I'm directly jumping to the event-driven microservice architecture. So what is this buzzword microservices? You might have start hearing about this microservices in last 4 or 5 years, it become very popular, right? Before that, we used to do the same thing, right? I've done the struts make all the coding and single server deployment, the architecture just now what I showed, right? So microservice architecture is basically if I need to define in a single line or single word, this is the single responsibility framework. So one person, if doing one task and doing, absolutely in a uh, fantastic way, then that is the microservice basically, theoretically. But we can talk about it more. Each of these microservices are responsible for discrete tasks and communication with the other services through the simple API to achieve a larger functionality. These components comes together to deliver the complete functionality. Okay, we'll see the example for the same, how multiple services talking to each other to deliver the bigger problem. And we are just breaking down that bigger problem into the smaller problem and then solving this problem. Now, this is how the microservice architecture will look like. Have you noticed any difference between the previous slide and this slide? The difference is each microservice, the slide not changing, somebody is saying that. Can you check? Otherwise, I will make it. It's working. Yeah. Working fine. Okay. I'll continue that. So if you see in this architecture, the big difference is each of this box, what you see under the dot line, having its own database, right? The each service basically is having its own DB, and then they are talking to each other through open APIs. Okay, you see the left and right arrows, they are communicating, these two services are communicating to each other, right? What does it mean? So microservice architecture basically have some key concepts. Okay. First is independent deployment. How can you do it without having this architecture? When you are saying independent deployment, that means the service need to hold the complete control, right? That means the service should have its own database, right? Each service should be independently deployable, right? Don't draw the hard line, because sometimes you will have a feature where you have absolutely logical reason to separate out and build two services, but they cannot work, in isolation. They need each other to communicate for the communication, right? It is not a hard line, but that's the concept of the microservice architecture, that each service should be independent deployable. That means it need to be loosely coupled. Okay. And this should publish the well-defined APIs so that other services can interact to the another service, right? If there are APIs available, then they can talk to each other, right? Then fault isolation and resilience. We talked about fault isolation in monolithic, right? If one functionality is not working, there are chances it will crash the whole system, right? One server is goes down, everything is stopped. But here, if one service is not working, then other will keep working, right? So there is a fault isolation. One service failure is not causes the another service failure, right? And we can avoid wherever we have such requirement that there is a dependency. with another service, right? And that service fails, then we can have circuit breaker, retry options, right? Just think about, let's say my database is down and I'm processing the request asynchronously. Okay, it's a event-driven microservice architecture. So we will be processing the request asynchronously. In that case, you can hold your Kafka consumer and say once the database is up, then read the other messages. Don't keep reading it, right? So this is how you achieve the resilience. So we know the fault tolerance and resilience. Model around VR. This is very important, and that we will talk about in the later slide also. Domain-driven design, which is like you need to understand your domain to design your microservices, right? Define the service boundaries for to achieve the domain-driven design. If you are not drawing the hard boundary for your microservice, then it will become a smaller monolith. If you will try to solve everything within that microservice, right? Right. This question, size of a microservice. This question I often hear from many people, whoever is working on microservice architecture. This is a very common question. How big my microservice should be? And because of the word micro itself, right? How big it should be or how small it should be. See, the concept of microservice is not defined in terms of size. Basically, it's not defined by the number of line of code you have written. Maybe something 10,000 line of code is smaller for me and may not be smaller for somebody else, right? It is a big code for that. So size of the microservice is depends on the what functionalities you are implementing for that microservice. And that's where I said DDD, which is domain-driven design, and have the hard boundaries there, so that you will not, implement unnecessary, not basically unnecessary for that particular service, unnecessary feature for that particular service. That may be important, but that might need to be implemented separately, right? Backward compatibility and versioning. This is super important in microservice architecture. If we don't have this, then we compromise on many things, right? What all things we compromise if we don't take care of backward compatibility and versioning. So first of all, let me talk about what is backward compatibility and versioning means. So backward compatibility, basically, if you have a service and which is exposing few APIs to the world and people are consuming those APIs, and if you want to make any changes to that service, right, then it should not break whoever is consuming those services, those APIs, right? It should not break their functionalities. That is what called is backward compatibility, right? So for example, I have an API, let's say create property. And if I want to add an attribute, new attribute, and this API is already getting consumed by 10 other vendors, services, or software systems, whatever it is, right? UI also can be one of the consumer. It is already getting consumed. Now, how can I add that new attribute so that it will be backward compatible? If it is non-mandatory, mostly you are sorted, right? But if it is mandatory, then it is problematic, right? And that's where there are two options we have. One is, there can be multiple, but I want to talk about two. One is you find out a way to make it backward compatible by, like example of, by providing some default value. If you are not providing, still I will set this value and it will go, right? This is one way of just making it backward compatible. Other is the versioning. You write another API, okay, and version that API and support provide for the N-1 API. So backward compatibility with versioning, both comes together basically. So all your API should be versioned basically, right? And when you make any changes to that particular service, make sure it is backward compatible. If it is not possible to make it backward compatible, then write the versioned API for that. Now, versioning again can be multiple type, right? In microservice world, versioning I can do at the service level, I can do at the API level, right? And then if you will get into the implementation, the versioning can be defined at the URI level itself, then header level itself, then data level. So there are multiple type of versioning. I don't want to get into the details of the versioning, but this is important to design a service, right? For designing, you don't need to know those approaches of how to do the API versioning and backward compatibility. Right? Then decentralized data management. As I showed in the diagram, each service have its own database. Often we have been working with microservice architecture so long, but still I get that question, can I join two services databases? As soon as you do that, then both service either will get evolved together, then we are losing basically independent evolve feature. You cannot then evolve in isolation those services. Okay? So make sure your database is isolated. Then only your deployment will be isolated. It will start all from the bottom layer. Right? Then monitoring and observability. It is important to have your monitoring and observability tools available for with the microservice architecture. Why? Because now you have a lot of services available, a lot of components available to monitor, right? You will not know because your website will be working, but your payment flow is not working. Now, how will you know? If your whole website is down, it's fine. At least you will come to know somehow. But you will not keep testing your one feature for all the services, right? That I will keep testing all the features, right? So for that, particularly, we need monitoring and observability, right? Then we have log aggregation and distributed tracing. In microservice architecture, it is super important because to do the debugging, we don't know when microservices are talking to each other. We don't know where it failed, right? So distributed tracing and log aggregation is important. You have multiple machines where your multiple instances of a single service are running, which is like horizontal scalability I just explained. So it's very important. There are tools available, like we uses Prometheus and Kibana, right? Okay. Yeah. Okay. Okay, so pros are scalability, independent deployment, technology, diversity. I want to talk about it. Like once you have decoupled your component, then you can choose the technology. Few services you can have in Java, services you can have in .NET, few services you can have in Python. So it is tech agnostic basically. You don't have a dependency on one service. One technology, sorry. Then robustness, of course, we have the fault isolation, so robustness will become easier, and business agility, because as soon as you will get the new functionality, you change that particular component where you feel it need to be changed to achieve the functionality without touching the other component. Right? Now cons. Now that's important. We talked about the good things about microservice architecture. Now let's see the pain points. It increased the complexity. Why? Because now you are managing the multiple components, multiple services. Like in eGov itself, we have around 30 core services, and then we have uh, around 40, 50 other domain services, right? So you basically you are handling 100 services, let's say, then it is complex. Then operational overhead, of course, because you need monitoring because of not large numbers of services, infrastructure provisioning, automation. Automation is important because you cannot keep testing the functionality if you are going with the backward compatibility and versioning. Trust me, QA don't remember after 6 months what it was supposed to be in V1, and I need to test both V1 and V2, and they really face the hard time. So having the automation is important for that, right? For deployment as well as testing, right? Is complex. Data consistency and integrity across different services. It's a complex task. Because if I'll just take example. I was thinking to take it later because I want to brief you about the government domain. But let me take that example right now. If you don't understand, please wait, be patient. You will understand it later. So let's say there is a property. All of you know you have the houses, right? That is your property. You pay the property taxes. Then you have the water connection at your home. Now, you give the water connection to a property, basically. You apply, you give the water connection to particular property. And let's say there is an integration which says based on this attribute, the water connection can be automatically given. Right? And but once you allocated the water connection, the price of the water also is decided already, because you have the residential house, the property type is residential. Now you can choose your slab according to the residential. As soon as I change that, I will update that. It should reflect in water also. Otherwise, your property becomes from residential to non-residential, and it happens very often, right? We rent our house, we give it for commercial purposes, right? It happens very often. So data consistency, it is not like you cannot achieve it, but it's bit of complex. So like second point we mentioned, that update and all in the data management will be complex. Then testing complexity, we have already discussed. Communication overhead, because there are multiple components. If you need to deliver a big functionality, you will need to talk to multiple components. So inter-service call will be there. If there are inter-service calls over the network, even through REST API, then also you will have some network latency. It can be 20 milliseconds, 30 milliseconds, just fine. But that complexity will be there, right? Then serialization and deserialization. This is more bit of a technical thing. I believe 80% people are technical in this session. So deserialization and serialization will happen for each service call, which will impact the performance. And overly chatty communication is big pain in microservice world, because it can impact your performance badly. If you are just, and it's when I'm talking about overly chatty communication, it is all synchronous, right? All synchronous performance perspectives. If it is asynchronous, then data will become problematic. Then basically you need to keep listening to those events which can impact your flow. Okay. So why we have implemented microservice architecture? Why not monolith? It is not necessary. Even I have been in some of the companies like where they asked, can we implement microservice architecture? And I saw the need and I clearly said, this is not the right fit for you. When you are choosing microservice architecture, there are certain criteria for that. First of all, do you need that scale? Okay. What microservice offers to you. Because dealing then with all this complexity, whatever we have just discussed, is not easy. So do you need that scale first? Second, do you have the capacity to deal with microservice architecture? Right? You need strong DevOps, you need architect who can design, your APIs, who can design your services, all of that will be there, right? Now, why we have implemented in DIGIT microservice architecture? And the major reason we have is the scale. That's the major reason. The second reason why we have implemented is because of the diversity. We are dealing with the government domain, and government domain is, it's fragmented completely. In India, I often say that in India, with every 100 kilometer language changes, and every 50 kilometer water taste changes. Right? Then think about the government rules and regulations. That first we have the nation, we have the state. After state, we have districts, cities, villages. Just think about this structure, and then we have the department. And rules changes from department to department, state to state, district to district, city to city. And that's the reality. Now, the simple solution for this, you can say, why can't they standardize everything? Trust me, it is not easy. See the use case of GST, how long they took, how much time they took to implement this, right? Still, you see, when you buy a car, the taxes are different in each state. Right? You cannot ride the same car which you bought at your home in Karnataka. So the rules and regulation will change. That means we need more flexible system for government domain. So there are two reasons. One is the scale. Why scale? Just look at, okay, sorry. Just look at this diagram. We are talking about the nation and we are dealing with the 1.4 billion people. So just think about it. The platform what we have designed is for the top level layer, which is like national level where we will deploy. And somewhat we are achieving through NUDM. Right, Kavi? So national level deployment, that's what we have designed for. Although we have implemented in state level also. But you cannot design for state level and expect to get implemented at the national level then, right? So that's the major reason we chosen microservice architecture. And of course, rules are, very diverse. And I will take one example of property tax, how we have broken it down and how it is helping to get it implemented in multiple states and even NUDM for that matter, right? So we have how many? 28 state plus 8 union territory, and then we have the local department, 4,000 local department, and this is all these numbers. Number doesn't matter, but it's a huge number, so we need to deal with it. So we need that scale, and that's why we choose microservice architecture. Now we are getting into DIGIT. DIGIT is basically a facilitator between government and citizens, right? It's a bridge which between citizen and government. Government basically deliver the services to the citizen. Citizen pay taxes, citizen pay charges for the services, right? So this we have certain principle on digit. First is open, and open means open. Our discussions are open. Our code is open. Our specs are open. Tech stack is open source. So everything is open. We don't use the commercial technologies. We even when we are deploying on cloud, we kept our deployment cloud agnostic. If you have your data center, you can deploy there. If you want to use AWS, Azure, or GCP, you can choose your deployment, right? Then evolvable. You can evolve your services, functionalities within that services. Once you take care of API versioning and backward compatibility that I have already discussed, then extendable. Why extendable? The reason is, just now I explained about we are dealing with the government domain, and government domain we will have this kind of requirement. I want 2 more attribute. It doesn't matter how good schema you are giving, you are covering everything. Sir, मेरे को तो 2 attribute चाहिए. Okay, so you need to be flexible enough so that people can cater their requirement, right? Your schema should be extendable. Although it is, the second point is very important. Extension should be documented in the same way like base model, right? That means you are defining your schema. Okay, these are the additional attribute I need, but these are well defined. Okay, and when we are defining those schema, absolutely perfect. So API should take care of that, and we will show you one of the example of the same, right? Then minimalistic, super important for adoption in government. And when we have discussed, like we are dealing with the diverse rule, minimalistic is the key principle of designing your service. Keep the minimum number of fields mandatory. Why? Because the reason is, in one state ka requirement aapne dekha, and you said height of the building is something is mandatory because they are calculating the tax on top of it. Fair enough? And you made it mandatory. As soon as you made it mandatory, then you cannot deploy it in another state because they don't have height of the building at all. For them, height of the building doesn't even matter to collect the tax. So we need to choose our attribute, what should be mandatory. If it is non-mandatory, anyway, you can make it mandatory later, right? With the API versioning, right? But if you are making it mandatory today, either I will be passing some junk data to you, right? That's the only way to consume your API, and that's how we stop the adoption then. Right? Then people hesitate to use the APIs. Right? We should not also define large number of APIs while we are designing the services. Let me take one example. Let's say you are, and all my example, I will keep it around property. So in the end, I will give one full design session on property also. So I'm just keeping to that level. I need to search the property. How many APIs I can create? Can you think about it? Search by ID, search by name, search by mobile number, and these can be separate APIs. Okay, search by mobile number, and then search by location, search by word, search by from date to date, and these can be separate API. But do we really need to make separate API for that? Or can we have one API which is like saying, give me your criteria, I will query the system and the result back. Because as soon as you design the number of APIs, so many APIs, then you end up with authorization problems, maintaining so much data for the authorization. Right? And then also versioning of the API again will become problematic. because as soon as you have so many APIs, if your schema is changing and you are versioning it, you need to version other APIs also, right? So we need to choose how many APIs we really need to achieve the functionality. Don't create get by ID, get by name, get property by ID, get property by name, get property by. If you will create so many API, it will become unmanageable. It will be a problem for authorization. किसको किसका access दूं मैं? Right? Whereas if you have that constraint, okay, somebody can search with these parameters, somebody can search with these parameters, you can have the configuration for it. Okay, who is allowed to search with what parameter within the single API? That's fine. At least you will not be, once you will do the versioning of the API, it will become very messier then, right? So data privacy and data empowerment, both in one box, looks very different in nature. Data privacy is basically you are hiding something, right? From the data perspective. And data empowerment is basically you are exposing the data to the citizens, to the government, so that they can do whatever they need to do. Okay. Let's say I'm exposing the property data, then at least the water department can interoperate on that property data and evaluate how many people have taken the residential connection, but they have the commercial property, how many people have taken the commercial connection, but they have, let's say, residential property, right? So data empowerment at the same time is important when we talk about the data privacy. Now, how should we distinguish between these two, and we are keeping in one box? So all the PII data, what we have, personal identifiable data, right? So like name, mobile number, address, these are the PII data, right? You secure those particular data sets, right? And other data, you can keep it open so that other services can operate on top of it and interop. Then we have non-reputable, basically don't create the API which can generate the similar kind of data every time. So you signed your data so that it cannot be generated again to claim, let's say I made the payment. By the way, you might have seen UPI, right? How UPI works. When you put your password, right, it signed your transaction and then sending it to bank. And what is UPI? UPI, does UPI have your money? No, it's still bank sold your money. It is talking to bank, but it is making sure the same transaction cannot be duplicated into the system because you have signed that data. Right? So non-reputable is important. Then secure authentication and authorization, and we have signed audit to securing the have the audit trail for signed audit, and authentication and authorization to access the resources. Resources means the APIs. And then unbundle. It's a very small term. I think people just understand with the word what unbundle means here, but it's a complex thing. It's a complete thought process, and I will show you when I will design the property. I'll show you why this is a little bit complex. Unbundling is like breaking your bigger problem into the smaller pieces. Please, if you want to break your bigger problem into smaller pieces, okay? Smaller problems and solve those problems, right? This is how we should do, but this is not like that straightforward. We will take few examples how we can break a big problem into a smaller problem, and then we can achieve the functionality whatever we need to achieve. Okay. So don't get scared by looking at the diagram. Okay. This is our DIGIT platform architecture. I will. Okay, so non-reputation is not yet implemented in Digit, and the reason is we don't have the electronics registry as of now. And second reason is we need the signing authority also, right? Somebody should sign it for non-reputation, right? But the signing authority with the government is not there as of now. But eventually we need to implement that. This is in our like signed audit is one of the example which even when I will explain about MDMS, signed audit we did not had. We had that principle in our blue book from since beginning, but we implemented I think 6-8 months back the signed audit. Okay, so let's talk about this architecture. So the top layer means above API gateway, these are the consumers of your APIs. And whatever boxes you are seeing here, currently, these boxes are basically are the common services, not all services. The common services what we have laid out here. And but the flow will remain same for all the services. Before I jump onto this slide, I want to show you one more slide. Okay. I showed you already, but before you see this, see, just remember this slide, right? What we have here is the load balancer, service 1, service 2, service 3, which has its own database, right? And this is what it is here, except the asynchronousness. I will talk about it. So how the flow works? How do you, I just need one input. Should I talk about all the services first and then architecture, or should I talk about the architecture flow first and then individual services? Just if you can comment in Q&A. You guys, architecture se start kar. Architecture flow, okay. Okay. So let me start with the architecture flow, then I'll get into the individual services. I think we are on time. We have 1.5 hours more, right? 1 hour. Okay. So the top layer you see all the consumer. It can be your UI, it can be your WhatsApp. These are the channels. Basically, multiple channels are consuming the APIs, right? Then we have the API gateway. Now I want to spend some time on the API gateway here because API gateway in our case does many things. Now, once the request is reaches to the API gateway, the first thing what it does, it inject the correlation ID. What is correlation ID? You remember in the previous slide, we talked about distributed tracing and logging, right? So the correlation ID will get used for distributed logging. When you write the log, all the logs will have the correlation ID. So if you are going one service to another service, the flow will be one service to another service to another service. The correlation to connect the complete request is the correlation ID. So it's important, right? So first it injects the correlation ID into the request. By the way, we are using Joule Netflix API gateway. And okay, most of the people you know Netflix Joules, right? No? Okay, I'll give you a brief about it. It has basically 4 functionality. It is a there are 4 features we have, which is like pre-filter, okay, post filter, route filter, and error filter, right? What pre-filter? Once you request to access any of the resources, before accessing the actual resource, whatever you need to do is comes under the pre-filter. I don't have. So that is pre-filter, and then post filter basically is once the request is processed by the particular resource, So for example, let me show you here. So if I'm making a user service call, user search here, okay, then what will happen? The pre-filter, all pre-filter will get executed at the API gateway level before even reaching the request to the user service, right? And then which one?
To show diagrams.
Let it. Okay, and then once user service will process the request and return the response, then all the post filter will get executed. Now between post and pre, there is a route filter, which will get executed to route your request to the appropriate service. Because as I said, just remember this diagram. What we have public IP at the load balancer level, and then we have the private IPs. So there will be service discovery also, right? Which will basically point to your service, and that is what API gateway is doing. So there is an incoming URL and it says map to this particular address, right? So route filter only route the request to the appropriate address, and then we have error filter. If there is any error in API gateway, then that filter can get executed. Okay. So what API gateway does in our case, inject the correlation ID. Then second pre-filter is authenticate the request. Before even authenticating, I think it checks first of all authentication and authorization required or not for the particular resource. For example, MDMS search, which is master data management service, what we have, which serve the master data for all the services. That is the open API, which is a whitelisted API. So that filter will not get execute for that authentication and authorization. So it check first whether the API is whitelisted or not. If it is not, then execute the authentication and authorization pre-filter. So it sends the token to the user service and validate the token with user service. As of now, we have implemented auth 2.0 for authentication mechanism, but we want to implement now, maybe probably next quarter, we will get JWT token. And the reason is why we are moving towards JWT token, because first of all, it is pre-signed token, which carry all the information within the token itself. I don't need to fetch it separately. Second is it can be verified offline. So I will literally avoid so many authentication and authorization calls here, right? So we will be implementing JWT in next quarter. Okay. So as of now, we are using OAuth 2, and that is why API gateway pre-filter has that call to user service to validate the token. Otherwise, it would have not made that call, right? Then authentication, authorization is done. Okay, the token is valid. Now, do you have permissions to access that resource, which is done by the role service, basically? It's called access control service also. So that validates whether you can access this particular API or not, right? If all this passes, then route filter get executed and the actual service will get hit, right? If you are trying to access the property API, then authentic correlation ID, authentication, authorization, and then route filter. Oh, sorry, post filter. Now, I will talk about the post filter and pre-filter. There is one more functionality we have implemented in pre-filter and post filter, but that is for the customization, right? Because we are dealing with the diverse system, fragmented, federated system. So basically, we need these two functionalities also, which is like customization at the pre-filter level and the post-filter level. And I'll talk about it. Just remind me, it is not in my slide. Just remind me, I'll brief about that. So the actual flow, how does it work? Basically, the request will go to can you no, wait, sorry, some problem. Okay, how do you point? Can you just slow that arrow? Annotate on this. Okay. Okay. So the flow is like authentication is done, authorization is done. Now the actual service, which can be any service, receiving the request and validating it first. So this is the event-driven microservice architecture. So that important thing is what before I jump on to the actual implementation of any service, what does it mean by event-driven? Event-driven, basically, you are emitting an event to perform any action in a asynchronous fashion. And when I say asynchronous fashion, basically it's a token system. Okay. Like in bank, you don't want to stand in queue, you get the token, and once you're you will get called out once your token will get executed at the counter, right? So basically, all the requests what we are doing is processing asynchronously. That means any service or the box, any service, what it is doing, performing all the validations. Format validation, business validation. Why? Because once you will publish it onto the queue, you are giving the token, basically the request is accepted. That means it is accepted. Should get success. At least percentage of success should be as high as it should be, right? 99% it should get success. Although it's hard to trust on your developers. All my developers are smiling. But yeah, the idea is basically all the business validation and format validations should be done at any service level. And then once all the validations are performed, then publish the event onto the queue, right? Once the you publish the event onto queue, then there are parallel consumer we have. This is the queue we have, and then we have the parallel consumers. One is the persister, what we have. Then we have the indexer, okay. Then we have notifications, right? And there is signed audit, which is not active on the queue, but it is active with the persister, right? So persister is basically persisting the data into the persisting the data into the database. This is what the persister is doing. Indexer is basically taking the same data, denormalizing that data, and sending it to the analytics DB. This is what it is doing. So this is the indexer, and you see this dotted line, right? So it is sending it to the analytics DB here. So this is what indexer, and these all are the parallel consumer. Okay, so think about the performance. At the same time, it is near real time. You are getting everything available for the reporting and dashboarding purpose also, and the data is getting into the database also, right? Then persister also will send it to the signed audit service so that the data is audited into the system in a signed fashion. You can verify it later whenever you want to verify, right? Then we have if there is any workflow within the service, then you see this arrow, the workflow can get activated here. This interaction. Now you may have one question here. Why workflow is synchronous? Why not asynchronous? Right? And that is debatable. It can be asynchronous, but we chosen to be synchronous here. Why? Because the reason was if the request is rejected by the workflow, right, then you should not process it further. And that is the reason we kept it synchronous. If it was asynchronous, then what will happen? I will process the request, then publish the event onto the queue. Workflow will pick up that request and then say it is rejected. Then it will publish one more event, the rejected event. And then you will reverse the transaction, right? Then because you have made it success already, right? So you will need to end up reversing the transaction. So we thought of this will be much more simpler for the implementation, and then we chosen to be synchronous here. Okay. Okay. So what I was saying, just when you are publishing, okay, I'll take questions later. Okay. I'll take these questions later. I'll just address your point. Basically, persistence is happening asynchronously. Index is happening asynchronously. Notification asynchronous, right? All of that is asynchronous. Then why workflow is synchronous, right? The reason it is debatable still, but the reason is to make workflow asynchronous, we need to do a little bit more work. And the work what we need to do is, once you accepted the request, the idea is, let's say somebody is saying, okay, I'm rejecting that request, but that need to be verified with the workflow first, whether you have authority to reject it or not. And workflow will say okay, it is fine, then you reject the request then and there. But if it is asynchronous, then you will publish onto the queue, and then workflow will listen to it, and then workflow will publish another event saying that it is rejected, and then you will revert your transaction, right? And that's how the whole flow works. Looking so confused, huh? So that's how the whole transaction will work. To avoid that complete flow, because the use case what we had from the product point of view, I'm just explaining this point. Somebody came to the counter and saying, sir, meri ye application hai, what is happening to that? And that guy said, okay, I'm rejecting it or approving it. Now, if I am doing this asynchronous processing completely, then how long that guy will keep waiting? And that is product view. Technical view, absolutely we have, but product requirement also says, of course, it is near real time, but we cannot say, कि boss, 5 millisecond, we cannot guarantee 5 milliseconds. What if my Kafka goes down, right? Now, okay, so persister is basically takes the JSON data from queue, and it has the mapping. Based on that mapping, it persists the data into the database, right? Then indexer basically take the same data, input is same, the output will be different, the place will be different. It will be persisting into the analytics DB, it could be Elasticsearch or whatever it is. Then before persisting, it will denormalize and omit some of the details, like all the PII data, you doesn't need to publish onto the Elasticsearch. That's it, right? We should not publish. Ideally, we should not publish it. So all of that work done by the indexer service. Then SMS is obvious. It is sending the SMS notification, email, and app notification are doing the corresponding job. Yeah, so the flow gets completed here, and then you return the response to the user or the caller, whoever is using that API. Now, when I just said, okay, I will talk about the pre-filter and post-filter again with one more requirement. Okay, so we talk about the government structure, right? How the government structure is, rules are different, so it should be extendable, customizable, right? I should be able to add 2 more fields if I need to add. But what if I can add it? It will get saved. I will get it written back also. But what if my requirement is I want to perform a operation on that field, a validation on that field, which is like if the value is between so and so, then only I will accept that request. It's the business validation, and otherwise I will reject the request. And that's where pre-filter comes into picture. Pre-filter at the API gateway level, we have implemented the functionality where you can activate a custom API for an incoming API, basically, which will get executed before even the route filter get executed. So before your actual service will get hit, before that, your custom service will get hit. And from there, you can reject the request. You can write the logic for this particular field. Okay, whatever you have added custom field, and you can write the logic for it and send it back saying that this is rejected or success, whatever it is. And post filter is basically, let's say you want to post filter basically once property registered successfully, then do this. So that is also its configuration in the API gateway. So these two more filter we have, and these two filters are only useful once you want to do some customization kind of thing. Okay. And although we have the event driven architecture anyways, so if you want to write, okay, from any service to queue, there will be one more service which will do this custom validation and reverse the transaction. That is also fine. But what we want is you do the less work, right? Then you will need to expose an API which will reverse the transaction basically. Right? Okay. So now I can talk about these individual boxes. I'll finish it in 15 minutes, and half an hour we will spend on property module designing. So user service, basically it does the authentication, authorization, and manage the user data. Now, the current user service what we have, and this actually little bit violating the principle of architecture what we discussed earlier, which is that single responsibility. It is doing basically multiple things. It is maintaining the user's data. At the same time, it is also doing the authentication and authorization. And so in the next version, whatever we will have for user service, and most probably in the next quarter with JWT and individual service, this mistake we will correct, right? Okay. Then we have role service. Once we will implement the JWT, actually the authorization can be done offline. Okay. The role service currently doing the authorization also, which is the functionality we will remove in future. The authorization will be completely offline. The role service access control service will basically serve the mapping between role and the what resources you can access. Right? That is the only job it will do. Okay. Then we have location service. So I talked about like the structure, India and state. Then we have district to city. Even before district, we have zones. After zones, we have districts. Districts we have cities. Cities we have ward. Ward we have block, and then block, locality, and street, then your property. So this is the complete structure, but it is not that standardized everywhere. Somewhere you will have block, somewhere you will have wards. It is not standardized across. So this location service, what it does, it maintains the hierarchies, government hierarchies. And there can be multiple hierarchies across the department. So one department may be following the different hierarchy, another department may be following the different hierarchy. So the example is property may be using the property revenue hierarchy, which has which is basically start from state, district, and then ward and Okay, ward and then locality. Whereas water may be following the different hierarchy and they will have block also in between ward and locality, right? So this is the location service we have. Then we have employee registry. Uh, that is basically manages the employees data, department, uh, uh, designation, assignment, all of that is stored here. One concept I just want to talk about. Uh, all the there is a relationship between user and employee. Okay, not basically user. As I talked about, the user is will get split into two services. One is the authentication and authorization service, and another will be the individual service kind of thing, right? Now, every employee is an individual, right? Currently, even in the current scenario, we are storing all the PIA information into the user service. Why? Because we are doing the encryption at one level, and we don't want to violate the principle of single source of truth for the data. So all the PIA data is going into the user service, citizen, employee, and everyone, right? But every employee is individual, basically. So the information will store there. Only the employee information, organization and employee information will store into the employee service. Okay, then we have encryption. So encryption service is basically what it do. It takes the JSON input, iterate over the JSON, and then do the encryption for it and return you the encrypted data. It has two APIs basically, encrypt and decrypt. Based on your role, what you can access. For specifically, it is for decryption. Currently, we have integrated this service with the user service only, right? Right. So only user service, because we have the PIA data available into the user service. So there only we are basically doing the encryption and decryption, right? Then we have master data service. I will talk about it separately. I have a separate slide on that. But it manages the master data for every other services. Okay. Then this is cover. Language service is nothing, it's a localization, file store to upload your documents and files, right? And what we are using is menu to integrate with different file store management services. Like if you want to store on AWS S3 or Azure Blob or your file store, right? Local file store. So Mino can take care of all of that. Then we have the billing service, collection service, payment gateway. These three are correlated. Now, as I said, Digit is basically focused on the government services, right? It is a bridge between government and citizen. So basically, government deliver the services and citizen make the payment for it. Right? So billing basically take care of the generation of the bills. Okay, and collection will take care of making the payment for the bill particularly. Okay. Then we have payment gateway. Payment gateway is for the online payment. That's a separate service. Why we kept it separate? It could have been combined with the collection service itself. But the thing is that payment gateway will change from state to state, city to city, who want to implement what vendor they are using, the vendors APIs, how they are supporting the signing and all of that, right? So it depends. It changes frequently, so we kept it out. Okay, then we have PDF service to generate the PDF files. We have telemetry to record the this is this user telemetry, which is like what user is doing basically on the UI, just to know the feedback, who is using what feature from the front end perspective, UX perspective, right? Okay, I think I think I'm done. We can move to the next slide. Why it is not changing? Not changing the slide. No. Try that also.
Where is the slide? This one?
No, no, no.
This is why the body is outside.
No slide only, but I want to change the slide. Why it is not changing? This is, oh, sorry. No, not changing. What you did? What is this? Why this is coming like this? Delete clear. This. Clear. Okay. Okay. What is that? Okay. Okay, so now we are actually getting into the design phase now. So design philosophy, it's basically think, design and implement. Think 400, design 200 and implement 100. What does it mean? So the basically when we talk about the services should be evolvable. How we will make it evolvable? Of course, backward compatibility, API versioning, all of that is there. But your design should support that also, right? So think 400, design 200, and then implement 100. From 100 to 200, you may go in next 3 year, 4 year, whatever it takes, right? But this is the philosophy we should have. And then another philosophy what we have is the convention over configuration and configuration over code. What can be done using convention? Okay, don't write the configuration for that. Whatever can be done using configuration, don't write the code for it. Okay, only write the code which is specific and it is not like configurable. Right? Okay, so as I said, MDMS service. So I'm basically why I choose an MDMS service because I have better use cases here so that I can explain how to design a service. So we started this journey in 2017 that we will be developing a platform which will be microservice architecture based, and all of that we had that requirement, right? In the first phase of the development, we figure out two, three things, that the performance is the key thing here. Okay, that performance can kill other things completely. And other major thing was that development time. The time what we got to develop the platform was scary. So we used to find out of the box solutions to implement things in a faster manner, right? So why MDMS service came into picture first of all? That we observed that each service, each module had 10 to 15 masters. Okay. And now think about if each module has 10 to 15 master. Let's take the average of 10. Then there are 70 services we are talking about. And for each master, you will write at least 4 API. Create, update, search, delete. Multiply by 70. Multiply by 10. So how many API we are talking about? Now think about if one module need to make 15 calls to get those details on front end every time. So performance get killed there. Another is now we are maintaining so much of code which is no use. No use in the sense there, see, master data, once you have the data now, there is no use of that particular code because it is not your business functionality. And it's a slow moving data. The definition of master data is slow moving data. For example, property type, residential, non-residential, and mixed. Now, will it get changed? Why do you need APIs for that? Why do you need UI for that? It will never change. And if you will change it, your flow will change then, business flow. Because you have written a particular flow saying that residential should have this and non-residential should have this flow. If I start calling non-residential to commercial, will code understand that code? No, it will fail, right? So it's a slow moving data. So the requirement what we had is, number of masters in each module, number of APIs for each module, reduce the development time, and then performance and maintenance. You will build the UI for it, you will build so many APIs, then test so many APIs. All of that was there, and we did not have time for it, right? So MDMS almost reduced the, I would say 30 to 40% of development time got reduced when we built this service. And literally we built it in 3 days, 2 to 3 days, I remember, MDMS. So even for Persister also was like that. So 2 to 3 days it took to, build this service and deploy it. Now I want to talk about how we are using MDMS. Okay, so what was the requirement first? Because this data is important to control your flow, we need signed audit, who change, what change, when change, right? Now, so by looking at the why, we were clear, and that's how design works, by the way. The designing is already started. These are the questions you need to ask. Why any feature is needed? You ask that question to your product managers also. And if you don't have the satisfactory answer, don't implement. Then follow the principle of minimalistic. Be minimal guy, right? So why certain feature is needed? So we were convinced on these things. Okay, of course, performance is getting impacted, and we face the failure also. So we knew that. And deployment time, APIs, all of these things were obvious. So we said, okay, fine, we need to have a service which will address all of these issues, right? So we needed signed audit, workflow, support for multiple master search in a single network call, and filter the data. These are the features they have asked for. Okay, these are the features we will need. Okay, then we chosen out of the box, as I said, Git. Why Git? Because first of all, the first and second requirement get satisfied there. Okay, it is a slow moving data, so we don't want that some ULB guy will open up the screen and change the data. Okay, fine. If once in a while it will come, this request will comes to the technical person, they will change the data. That's fine. So we are storing JSON file in Git currently. And when I'm saying currently, now we have time. Now we understood that sometimes people need those screens also. So we will be moving away with the Git very soon. And also we have the signed audit also, no? So that service is available. So bunch of things are now in favor of to moving from Git to database. Then cache the data for faster search, use Git sync to sync the data between Git and MDMS. So this is what we have came up with. This is what we will do, and this is what we implemented. And the first implementation, I remember it was taking around, because every single service was making so many calls to MDMS. So we realized very soon, okay, yaar, this is something wrong with this service, because it was taking, when you increase the load, it was taking around 300 milliseconds to respond back. And then we again took that service and refined it in another one day we took and then refined it. And I think now it takes 0 to 1 millisecond to respond back with the master data, literally. And you can ask for as many master data as you want in a single network call. Single network call you make, ask for 20, 30, 40 master data, it will return you within 20 milliseconds, right? So, so this is about MDMS. You can post your question on MDMS also. Okay, let's design the property tags. We have some time. Okay, so let's say I don't get into the details of the requirement too much. On a high level, I just want you to see the requirement. So high level requirement, what we have is assess the property, okay, and calculate the tax, generate the bill, send the notification, collect the payment in offline and online mode. Okay, this one, okay. This is fine. Okay, so now we are actually starting the design exercise here. Okay, this is the requirement we have. Now, when you remember the design philosophy we just talked about, think 400, design 200, and implement 100, right? Now, what is the simplest design for this service could be in microservice itself? And we discussed the core services also. So we know, okay, notification we don't need to build and we don't need to design because core services are available. What we are designing is the property tags, okay? Notification we don't need to design. Payment we don't need to design because we have the billing service and collection service, right? Okay. Bill generation we need to design, right? Calculation piece we need to design and assessment we need to design, right? So let's start from there. Okay. So we have seen the digit architecture and this is how it will be, right? The first design, high level design. Agree? Assess the property. It will generate the bill to the billing service. Then you will come for the payment and make the payment. It will fetch the bill from the billing service and you will make the payment here, right? This is a high level design. So far, so good. Just focus on this green box. Okay. Now what I will be doing is whiteboarding little bit so that I can explain the problem with this. Already have a box. Please remember the diagram. Okay. So now think about the green box. Okay. The green box we had, this is property service, right? Now what all things it is doing? This is doing the assessment of the property. Assessment is nothing basically. you are capturing the details of the property, right? So property details, basically I can say, right? Dealing with the property details. Right? Then it has the calculation engine. Right? Now, let's say with the same requirement, product manager comes and say, okay, boss, there is a one-step approval process is also there. Okay. Then it becomes little, okay, fine. We will have workflow also, right? Now, this is what this service is doing. Now, we need to understand that the principle of microservice architecture shouldn't be doing so much. Should I break it down and have the separate component? Now, before doing that, I wanted to analyze each of this requirement. The first question you will ask to your product manager, it was, tell me, what did you mean by property details? Right? They'll say property details, what we have is about the land information, right? What is the plot size, all of that, right? The location, which is nothing, is the address of the property. And then what we will have? Owner information. Who is the owner of that property? What else? Then property detail. And then property details means like the construction detail. How many of you know when you bought a house, then that time you need to pay the taxes according to your what material you have used to build your house. The registration fee, what you pay, if it is tiles and marble, it will be different. If it is plain first, it will be different. Right? So that is what the construction details means. Right? So these are the high level information you get. Now you understand, okay, owner information will integrate with the user because that's where we are keeping PII information. So all the PII information will go here, right? Now other information we will keep in property, which is non-PII data, which is not stored by any of the registry. Now location information will be there, and then detail about the property. So far, so good. I think I would like to make it interactive a little bit now, these 15-20 minutes. Okay, now what I want is people can post their question related to this design section, basically, if they want to post. And if you guys also have any question, you can ask. Okay. Other question we will take once we will be done with the design. Okay. So this is the information we have, and now we know this property service is doing so much. Okay. Now this section is sorted. We know something about it. Now this section, calculation. Now the first question you will ask, what is the formula to calculate the tax? How you are identifying how much tax the person need to pay? That depends on the property detail which the product manager responded. Depends on the property detail. Okay, fine, property detail. What if my plot size is 1000 square feet and somebody is 10,000 square feet? Then how these rates are getting decided? Okay, we need to have something called billing slab then, because it will get multiplied by 4. So 4 rupees per square feet is the house tax you need to pay. As soon as you will get this requirement, it should trigger a boss. This is 4 in particular implementation. but it will change in another implementation, right? So the first bifurcation you should do is, I'm just erasing this piece, okay? Okay, so let it be. Let me take it here. We had one service, green box, property service. Now we have property service and calculator service. This piece we need to abstract it out. Why? Because just because this information will be consistent across. You may add 2 more field here to calculate your tax, but I'm pretty sure this particular box will change place to place, city to city, state to state, right? So what I want is I should be able to plug out this particular box and plug in the new one. Yeah. Plug out and plug in, right? So this is done. Now what? Now we know the property service is dealing with workflow. Okay. And user integration and property integration, right? Property data, sorry. Property data, right? This is what it has. Now, the next question you should ask, calculation is now become an independent component. The next question is, what all operations I can do on this property? Maybe in B1 version, they will say only property tax payment. Okay. Then I will go with this design where I will have my UI, okay, and then property service, and then calculator service, and then calculator will be calling to billing service, and right. So this is how the flow will be, and this will publish onto the queue, and then there is a persister. This part I just want to leave. Just focus on the left. It is okay. So just focus on that. So what we have is the calculator, we have bill, we have, and then payment. Right? So payment is independent of this piece. Once you generated the bill, I can make the payment. Who is responsible to generate the bill? Calculator. So the calculator is only has one dependency, which is on bill, because that's the only damn thing it is doing. It is calculating the tax and generating the bill for it, right? Then we have property service. Now there is a scope of think 400, right? This is design 200 is done. Now think 400. Now think 400, there will be operations on the property, further operations on the property. What all operations will be there? And we know that either product manager will tell you or you will know that, or you should read about it, whatever domain you are working on. And
questions regarding the calculator service and processes, so if you can respond while you are saying.
Ravi, can you come?
Oh,
you respond to this question, whatever you, okay. Whatever you are not responding, just let me know, I will take that. So now think 400. Start from the other operations. What is possible? So there are on property, you sell property, you buy property, right? Then भाइयों में झगड़े होते हैं, बंटवारे होते हैं. You bifurcate the property then, right? Then you buy another plot just beside your house, then there will be amalgamation of the property. So you know there are a bunch of features will be there in future. This is not the requirement for today, right? This is not the requirement you have. but you design for it. So if you will design for it, what is the fundamental things will not change from the attribute point of view? The fundamental things will not change is the property details. You will have the plot size, even though you bifurcate or amalgamate, the size may vary. It can reduce, it can increase, but still the fundamental will remain same, right? So what do we need? A property registry, because that is the very, very slow moving component. This will never change, or if never change in the sense, you will add a few more attribute, but fundamentally, now this is the box we are just breaking it down. Okay. So what we have here now, property registry, and then there is a property service, and there is a calculator. Now these are the services from that requirement, property requirement only. Now registry will deal with the what APIs? Create, update, delete, and search. These are the only API registry will offer. Right? Why? Because the operations, whatever we are discussing, mutation, bifurcation, amalgamation, or whatever it is, all are eventually the same. Like if you are mutating the property, that means you are basically changing the ownership of the property. It's the update on the property details, whatever existence, right? If you are bifurcating the property, again is an update on the same property. You may be linking to the parent property, right? If you are doing amalgamation, basically you are merging two properties. Again, what you are doing basically? Changing the, updating the property details, right? So this will have those APIs. Now all these APIs mutate, mutation, amalgamation, amalgamation, assessment, all of that will be there, so that it will be dealing with workflow, because each flow will have the different workflow. Mutation will go to the different department when you are changing the ownership, whereas when you are changing the property detail, it will go to the different department for approval. So workflow will be here, and this will be working in isolation. And why we have done this? In future, we will have a requirement that we talked about initially, that we need to give the water connection for other property, right? So you integrate your water module here itself. Now, when you do that, do you have the dependency of deploying this service or this service? No. And that's how you do the isolation. Right? With 3-4 services, if we had one service which is having calculation, all workflow maintenance, everything, that is also microservice architecture, but bad one. You can basically, what you are doing, you are separating out the module. You are not basically building the microservice, because one service is doing multiple jobs. And when it is doing so many things, if I don't want property module, but I want water module, basically आप तो मेरे को चिपका के दे रहे हो calculator भी अपना, isn't it? Right? So calculator is just coming, even I don't want property tags. I want only water. But water का base क्या है? Is property. It issued on the property, but not on the text piece. Right? So this is how we should do the designing. I'll show you. We have 5 minutes. Okay. I will take another 5 minutes, then I'll take the question for another 10 minutes. People can just, sorry, it got extended little bit, but I want to talk about the Swagger specification. Some standard we should follow when we write the Swagger specification. Your API contract basically. Define the version API. So whether you choose, I don't want to force, but in Digit, if you are designing a Digit service, the version should be available with the path itself, URI itself. Okay. Then min length, max length for each attribute we should define. And that min length and max length should match or at least match to the database, or your database min length, max length should be more than this min length, max length. And when I'm saying this, what does it mean? Because we are processing the request asynchronously. If you have defined name only 20 character and in database you define 10 character, what will happen? You will pass the validation. If the person is sending you 20 character name, you will pass the validation, but it will fail to persist into the database, although you have sent the successful response to the consumer, right? So this is the problem. So make sure, please, it's a request, make sure all min length, max length are defined in the Swagger spec. And when you create the table, use the same min length, max length, or increase it, right? Date always should be in epoch. Otherwise, you will fall into a trap of, local time and all, doing conversion for time. So do the conversion when it is needed. If you are displaying somebody, then do the conversion on that particular place. But on the server side, everything should be epoch. Call out the mandatory and non-mandatory field and follow the principle of minimalistic here. Don't blindly make everything mandatory. It doesn't help you. Trust me. Adoption will go for a toss. Once you will move from one state to another state, it's gone. Regex for fields, if there is any regex needed on a particular field, you can define that. Read-only fields, basically whatever server generated IDs are there, call out those in a specification, API specification, right? Error codes, enums should be called out, what all error codes you are sending. And description and example, it is super important. If you don't want that people should bother you every time when they are consuming your APIs, you should have the better descriptions for each field. Okay. Otherwise, everyone will keep coming to you. Boss, why this field is there? What is the use? Right? Okay, description and example ho gaya. Refer common objects. We have request info, we have audit details, then we have address, owner is nothing like individual persons. These objects we have already standardized and published as a common contract. Refer it from there. Don't define your own specifications, right? Okay. So, Dhanyavad. I want to show you one Swagger spec, but I don't think the time will allow me to do that. So what I will do, I will send it over the email. Have a look. It is for the property only. Just want to show you the sample of how the Swagger spec will look like. Have a look. And when you design your API, just make sure it is 80% aligned with the same one, right? Okay, I can take the questions now.